Alright, this is Mr. Pandy, and I'm just coming to you guys to talk about the quadratic formula and how we use that for the homework that we got. Okay, so everybody should already have this quadratic formula written down in their notebook. Okay, if you don't, you're lacking and you're slacking, and I don't know what's going on with you. All right, so this is the quadratic formula. This is based off of trying to find the x-intercept of a quadratic function when we cannot factor. Neither can we do the completing the square, so the best method is going to be the quadratic formula. Okay, these letters B, A, and C, they come from the quadratic expression when we have something that is squared, right, plus something else, and those somethings will be ax squared plus bx plus c. So this is where the a, the b, and the c come from in the quadratic formula. Okay, and this a, b, and c are replaced with actual numbers. All right, so let's go ahead and do an example real quick. Okay, so we have let's say you got Josh drops his phone from a height of 50 feet. The situation is best modeled by h equals negative 16t squared plus 50, where h is the height in feet and t is the time in seconds. How long will it take for the phone to hit the ground? Round to the nearest tenth. Alrighty, so we already have a formula. Sorry, we got a situation right here where we have it says h equals negative 16t plus 50. Okay, so this right here, this negative 16 goes with the a because it's right next to the variable that is squared. We do not have anything at all right here for this one with just a linear term, but we do have a constant term. So if I want to write this over again, I could just say this is negative 16t squared plus 0t plus 50. So therefore you can kind of see that right away that negative 16 is going to be a, 0 is going to be b, and then 50 is going to be c. Alrighty. So from there we plug these into our function like this. Okay. And I'm going to type that into the online scientific calculator. Okay, so I'm going to come here and I'm going to do this. Let me clear this out. So I'm going to make a fraction already. So I'm just type out the function first. So therefore I'm going to replace everything. We don't have a plus or minus. I'm going to start with the minus part first, and I'm going to say square root of minus 4 times a times c. Ooh. About 2 times a. Okay, so that's the actual formula that we have for the quadratic formula. So I'm going to replace a, b, and c with our numbers. Okay, so we already know that b was 0, so I'm going to put a 0 here, put a 0 here. A was negative 16, c was 50, and then of course a was again negative 16. Okay, alrighty, so one of the answers here is going to be x equals 1.76, or t equals, I should say t, not x, but t equals, let me just wipe this out, t equals 1.767. oh my god, I hate that 6-7 stuff, but anyway, so I got that part already right here, 1.767, and then I'm going to change this right now to find out the plus part, and the plus part is a negative 1.767. Okay, cool. Alright. So these are my 2 times, okay, that I have for this quadratic formula. These are my 2 solutions. Now remember, we're talking about time here. So time can never be negative. So since time can never be negative, we cross this out and then we go with this one right here. Okay. So basically what we're saying is that if he dropped his cell phone from this particular spot, then it's going to take about 1.7 seconds for it to hit the ground. Okay. Or we could really round it to the nearest tenth and we could say 1.8. Okay. So we can say t equals 1.8 seconds. And that's all it is. You just plug in some stuff into the formula and get your answer from there. Okay. So going back to here, I'm going to say 1.8. Check the answer. Boom. Cool. We got it. Alrighty. Go on to the next one. So this one's a really tough one right here. So this says the town of Smallport plans to build a new water treatment plant on a rectangular piece of land, 75 yards wide, 200 yards long. The buildings and the facilities need to cover an area of 10,000 square yards. The town zoning board wants the site designer to allow as much room as possible between each edge of the site and the buildings and facilities. Okay, let X represent the width of the borders. All right, cool. So here's the building and the facilities. They got a little bit more extra room for the borders or whatnot. So we don't know how much that is, but we do know that if I was going from buildings to facilities plus this little extra borders right here on both sides, it'll be 200 yards. Okay, so if I just wanted to find out how much the buildings and facilities is, I would have to take the 200 minus this X off of this part and then minus this X off of that part, and that's how much the buildings and facilities would be. Okay, and the same thing for the width as well. If I want to find out how wide it is, of course the whole thing is 75, but if I just wanted to know how wide just the buildings and facilities part was, it'll be 75 minus this X part right here, and then minus this X part right here, and then also minus this X part right here. Okay, so I'm going to write that out first. So because it says write an equation to represent the area covered by the building and facilities. Write the right hand side of the equation as a product of the length and the width of the buildings and facilities. Okay, so again, this was a pretty tough one, so that's why I'm helping you guys out with this one. Okay, and as you can see, they already got 10,000 right here. Now what does the 10,000 represent again? It represents the area of the buildings and facilities. All right, so what I'm going to say is that, remember, we have area equals length times width. Okay, so if the area is supposed to be 10,000, okay, and going back to the actual problem itself, they say that the land is 75 yards wide, so this is the width right here. Okay, so if I just wanted the buildings and facilities, see how long they were or how wide it was, it'll be 75 minus 2x. Okay, so I'm gonna write that down right here. So I'm gonna say length equals 75 minus 2x. Okay, the width, that was like 200, right? Yeah, 200 for the whole thing, but just buildings and facilities, which is right here, I have to take an X off of that part and another X off that 200. So I have to take off 2 X's off of that. Okay, so that's why this right here is going to be 200 minus 2x. Okay, so now if I put everything together inside of this equation right here, I can have 10,000 equals 75 minus 2x times 200 minus 2x. Okay, so that's how I write it, and that's how they wanted you to write this particular one right here. Okay, so this is going to be, they already got the 10,000 right there, so all I'm going to do is I'm going to just say parentheses 75 minus 2x times 200 minus 2x. Check that answer, and boom, there we go. Okay, now the next problem number 6 goes with this, because now they say write the standard form of the quadratic equation. So they want us to go from what we have to the ax squared plus bx plus c, and it has to equal 0. Okay, so what we do is, in order to get that, that means that we're going to have to multiply some things here in order to get that. Okay, so I'm going to take this 75 first, and I'm going to multiply it to the 200. Okay, now if I do 75 times 200, that's going to be 15,000. Okay, so I'm going to have 10,000 equals 15,000. Okay, now I'm also going to take this 75 and multiply it towards the negative 2x. Now you might be asking, okay, Mr. Payne, hold up, you're going too fast. Like, why are you doing this? Well, again, I need to switch from this type of formation to a standard formation. So in order to do that, I need to multiply I need to multiply these two things together. I need to actually multiply the length and the width. Okay. So again, 75 times negative 2x is going to be a negative 150x. Okay. So we distributed that. All right. Now we're going to take this negative 2x here and multiply that towards these two terms over here. Okay. So negative 2x times 200 is going to be a negative 400. Oh, wrong marker. And then negative 2x times negative 2x is going to be a positive 4x squared. Okay. Now, if I look here, I can combine these two terms together right here. So when I do that, I'm going to have 10,000 stays the same, 15,000 stays the same. I just combine these two together. It's going to be a negative 550x and then plus 4x squared. Okay. So now I have it in standard form, but so I got the x squared part, that's going to be 4. Okay. I got the x part, which is a negative 550. I think I have the c. Here's the part. The thing is that I have 15,000, but it's equal to 10,000. So, and I need to be equal to 0. Okay. So in order to do that, I need to subtract the 10,000 from both sides. Okay. So minus 10,000 here, minus 10,000 here. Of course, that's the bell. Okay, so that part now is 0, and it equals 5,000 minus 550x plus 4x squared. Okay. So now we can put that as 5,000. Okay. So now it says find the width of the border. Round your answer to the nearest tenth. Okay. So now all we're going to do is that we're going to use, this is A, this is B, this is C. We're going to plug that into the calculator that we have for the quadratic formula and find out what we're going to get from here. Okay. So take that out. Take that out. Get this all from the last question that we had. All right. So B is negative 550. This is negative 550. A is 4. We said that already. And C was 5,000. And then again, A was 4. Okay, cool. So one of the possible widths could be 127. Okay, that's one of the possible ones. So we could say X could be 127. We'll say 127.71. Okay. Now let's change this plus to a minus. Another one could be 9.78. Now, which one do we choose? Okay, because they're both are good solutions, but we got to see which one is going to fit the actual problem. So let's go back, okay, because it says right here, find the width of the border. Round your answer to the nearest tenth. Where here's the thing. The thing is that if the whole piece right here is 75 yards, if the whole thing is 75, that means that the borders themselves can't be 75 because you got the buildings and the facilities. Remember, they only have a length of X. So if the buildings and facilities already take up something, then that means that these borders right here got to be less than, of course, 75. So one of our answers automatically we can't even use. Okay? And that answer is the 127.71. Okay, that's already bigger than the whole width right there. So we're not going to use this one right here at all. We're just going to use this one. Okay? So that'll be 9.78. And if we round it to the nearest tenth, it'll be 9.8. Okay. So this right here, we're going to go back. And we're going to enter this in as 9.8. Check our answer. Boom, there we go. We got it. Okay. So that's it. I'm gonna come back for a part 2 because I'm gonna do this question right here, and then I'll do the last question as well. Okay. Alright. Holla at y'all later.